Welcome to this video on how to calculate permutations when certain items are repeating. Another word for repeating that they use is indistinguishable. Meaning, of course, there are certain items that you can't tell apart from others. So in this example, we're going to find the number of ways to arrange the letters of the word pool. So the indistinguishable items are the two O's. So to figure out how to do this, first let's pretend that the O's are different. We'll call them O1 and O2. Right here. So in that case, your word would be P O1, O2, L. So if we pretended that the two O's were two different things, then there would be 4 items. So there would be 4 factorial ways of arranging them, which is equal to 24. And right here are the 24 different ways of arranging the letters of the word pool, assuming that the two O's are different objects. Now, of course, we're not going to spell the word pool with O1 and O2. We're going to spell the word P-O-O-L. So if you were to switch the two O's, the arrangement wouldn't be any different. So out of these 24 arrangements, these two are actually the same. These two are actually the same, because if you just switched the place of O1 and O2, you would have the same arrangement. These two would be the same, and etc. This means if the two O's were different, there would be 4 factorial or 24 ways of arranging those 4 letters. But since the two O's are the same, there are 2 factorial ways of arranging those same O's. What we would have to do is divide this by 2 factorial, which is equal to 2. So 24 divided by 2 means there's really only 12 different ways to arrange those letters. And here are the 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because, of course, within each of these circles, this and this are going to end up being the same arrangement. So, in general, repetitions are taken care of by dividing the permutation by the number of objects that are identical, and that's not an exclamation mark, that's a factorial. So we're going to divide the total number of arrangements by 2 factorial, because there's 2 factorial ways of arranging the two O's. That means we have a duplication of 2. Let's take a look at this example. How many different 5-letter words can be formed from the word apple? And remember, when we say different 5-letter words, we really just mean how many different arrangements. So the indistinguishable items in this case are the 2 P's. So you first pretend that they are different, and there are 1, 2, 3, 4, 5 letters. That means there are 5 factorial ways of arranging the 5 different letters. But because there are 2 P's, we're going to divide that by 2 factorial. And that works out to 60 words. And again, by words, we really just mean arrangements. They're not real words. How many different 6-digit numerals can be written using all of the following 6 digits? That means if we took these 6 digits, it's just saying how many ways can we arrange those 6 digits. Once again, you take how many total objects there are, which are 6. So there would be 6 factorial ways of arranging all 6 digits if they were indistinguishable. But you've got 2 4s, which means we have to divide this by 2 factorial. And we also have 3 5s. So on top of that, we also have to divide it by 3 factorial. And that would make 10 ways of arranging all of those letters. In short, what you really do is you take the total number of objects, which is n factorial. N is the total number of objects, and you divide it by a factorial, b factorial, c factorial, etc. However many factorials you need to, based on how many identical items there are. There could be just one set of identical items like this, so you'd only divide by 2 factorial. There could be 2 sets of identical items, so you'd have to divide by here a factorial, and here would be b factorial. If you had a word that had 3 sets of identical items, then you'd have to divide by 3 separate factorials. So that is the end of the lesson. If there's anything that you didn't understand, just make a note of it in the side and we can take it up in class.